Okay, let's get on with this module for today. That is oil tanker calculations part 2. The target audience are basically the phase 1 competency candidates, and all others also will find it useful because it's more or less something what we do on board a ship also. At the conclusion of this module, the participant will be able to understand. We'll do a recap of whatever we did last week, just the basics of the oil calculations. A very quick recap. We'll do a small calculations on the cuboidal tanks without any list on trim, so that the basics are understood, and then we can proceed on to the higher concepts of it. The effect of trim on the tank levels, then the effect of list on the tank levels. We'll be looking at it separately so that we understand the concepts of it. And then finally, we'll be summarizing the whole thing and then do a small calculations for this. During the course of the modules, there'll be some numericals, some calculations will be involved. So please keep your pen, paper, and a scientific calculator handy. This time I need a scientific calculator because we'll be doing some trigonometrical ratios calculations. That's the reason for doing it. And like I said in the last class also, the target audience are the candidates appearing for phase 1 competency exams. So the main objective over here is to prepare the candidates for the examination. And it may or may not be used on board, actually or used on board a ship, but that's a different thing. But to understand the concepts and how to go about doing it, that's what this whole class is about. Okay, we'll do a quick recap of what we did last week. So we saw that there are various ways of determining the volume of the oil in the cargo tanks. We can use a sounding tape. That's the first one. We can use an ullage tape. Second one. We can also use a radar gauge, or we can use a float gauge. So depending on the equipments on board, depending on the systems, we can use either one of them or like a multiple of all these things. Ultimately, we find out the volume of the oil. That's a whole concept of doing it. So when we get the once we come to the ullage, we subtract the height of the tank from it, and then from there we get the value for depth of the oil. Once we know the depth of the oil, then we just multiply it by the length and breadth of the tank, and we'll get the volume. This case is only for upright and even keel. It's not applicable for the ships in case she has got some trim or list. Once we get the volume of the oil, this again we discussed last week. For a given volume of oil, temperature is reduced. If the temperature is reduced, the volume reduces and the density increases. And the formula what we use is volume is equal to mass is equal to volume into density, provided that the volume and the density are the same temperature. And we also saw the standard temperature what we use for all our for calculating all these factors and all is 15 degrees Celsius. And we have the tables, various tables for this connected to this 15 degrees Celsius, connecting the volume and observed temperature to 15 degrees Celsius. We also saw last time what are the various uses of these ASTM tables, and this again I want to remind you, this is an examination copy. This is not the copy actually what you use on board a ship, but then what you use on board a ship is also more or less similar. So we have something called ASTM table 54, T54 we call it for short, and there we enter it with the observed temperature and the density at 15 degrees Celsius. This density at 15 degrees Celsius is given to us by the cargo surveyor, and it's you can see it sometimes in the bill of lading or sometimes in the certificate of the quality certificate or certificate of analysis. So you will get the density from one of these places. The density is density at 15 degrees Celsius and in vacuum, and this is the observed temperature. And we come to this thing called VCF. We also use another table called table 56, that is WRF, weight reduction factor. So we don't use this right hand side part of it, only the left hand side part is used. But we have seen, as in the last class, if you have seen, we don't actually have to use this also. There are like what you call, we can use another method instead of using this table 56. So in effect, only one table to be used, that is this table 54, and then we can get our answers from this. Again, this is a recap of last class what we did. In case you want to convert from ullage to volume to metric tons, that is ullage to volume to metric tons, we first obtain the volume. Volume is height of the oil into length into breadth. Next thing is we multiply this observed volume into VCF, and what we get is the volume at the standard temperature. We find out the density in air. Density in air is density in vacuum minus decimal 0011. And finally, when we multiply this density in air by this GSV, we get what is called as weight in air. So the next 4 steps are basically in case you want to go reverse. That means in case I want to go from the weight in air to volume. That is what this reverse process is. That is required in case we know the quantity of the cargo to be carried. Let's say like your stowage plan, we decide to carry a certain amount of metric tons in the tank. How to get the observed ullage? That's what the second step is for. That's only for your information. We won't be using it right now over here. So any doubts in this, the quick recap what we did? Basically carry forward from the last class.
No, sir.
Okay, great. So we go to the, before we go to the actual calculations of list and trim and all, let's do a simple calculations on based on this what we've seen so far. So what I want you all to find out is what is the ullage of the oil and weight. That is how much of the ullage of what will be the ullage of the oil in the cargo tanks, and what will be the weight of the cargo in the cargo tanks. And these are the various conditions what is given. I'm also giving you table 54 for your reference. So observed temperature is given, is known to us. Density is also known to us. That means we can use this table 54. And the tank is 98% full. There's also information which the question is, is given in the question. The tank dimensions are given. So can we find out this particular answer? Anybody? How to approach? Please unmute yourself and then speak.
So first we found
98%, 0.98
total volume
is the ullage section.
tank.
Yeah. So the first one, what we want to find out is the ullage of the oil. So let's start. Please always start with a small diagram which represents all the detail what is given in the question. So we have these informations which is like 18 is the breadth, 25 is the length, and this 30 centimeter, that's 0.3 meter, is basically what is like 98% full. That means 0.98 into the height of the tank will give us the distribution of this height. That means the oil level is 14.7 meters. Once we get this, we have to find out the volume of the oil. So one part of the question is already known to us now. Ullage of the oil is known because ullage is basically 0.98 of the height of the tank. Now we come to the second part, which is the volume of the tank, because next we want to find out what is the weight of the tank. What is the weight of the oil in the tank? So the volume is to be found out first. Now, can anybody tell me what volume is this? Is it standard volume or is it observed volume?
Observed volume.
Observed volume.
That means it's an observed volume. We can't directly use it with our density. We have to do it. We have to do some more like modifications to it. So next, this is a TOV. This is 25 into 18 into 14.7. That gives us 6615 cubic. That is the observed volume, TOV. So O stands for the observed volume. Next, we will start using the tables. So 26.5 is the temperature what is given, and the density is 785. That is 785 over here. So where these two meet, that is 9890. So this value of VCF is 9890. So now from this page, what I've calculated is TOV and the VCF. Now I don't need the tables, I don't need the diagrams because I already have this volume already calculated and the VCF is already found out. So we go to the next step, that is from the observed volume, how to find out the weight. So the first one is GSV. Can anybody tell me how to find out the GSV?
Observed volume into VCF.
Volume into VCF, very good. Observed volume, be careful of which volume you're referring to. Observed volume into VCF, that gives us the GSV. Now, this is simple multiplication. That means we get the answer as 6542, decimal 235. Next, what we find out is instead of going to table 56 as what we decided, we will follow a simpler method, that is density in vacuum minus 0011. Then when you do that, we get the figure of 0.7839 tons per cubic in air. That is the density in air now. So now I got the density in air. Now I got the standard volume in air. Now what has to be done?
Weight in air.
Yeah, weight in air. So how do we do that? Multiply these two. Very good. That means it's a simple multiplication again. So if you actually see, the procedure is very simple. You don't even have to. If you're using a scientific calculator, it's a regular progression from one to the other. So even though the formulas look a little daunting, the fundamentals are very, very simple. The calculations are even more simpler. If you get these concepts very, very straight, the concepts are pretty clear. If you get it straight, if you get it cleared, then no issues at all for solving these problems. Any doubts in how we did this problem?
No doubts in chat, sir.
Okay, great. Because this was just the basic. And before we go into list and trim, I just wanted to ensure that this basics is very, very clear. Because what we are up to about this level is second mix level. Now what we are going to go next is about phase 1 level. So I want this particular portion very, very clear to everybody. Okay, so no questions. So we go to the next part. We are going to use some trigonometrical, like what you call ratios and all. So just a basic of trigonometry. I know most of you are already aware of this trigonometrical ratios and all, but just a quick recap. First of all, what is sine theta? Anybody?
Opposite by hypotenuse. By hypotenuse.
Opposite by hypotenuse. Very good. Okay, I just got a small suggestion over here. Always use the opposite, adjacent, and hypotenuse. Don't say vertical and base, because if I change the theta, then the vertical becomes the, the whole concept of vertical and this all changes. So always use opposite, adjacent, and hypotenuse when we're referring to these trigonometrical ratios. So opposite by hypotenuse, very good. What is cos theta?
Adjacent by hypotenuse.
Adjacent by hypotenuse, very good. And now tan theta?
Sin theta by cos theta.
Sin theta by cos theta. So we have opposite divided by adjacent.
Adjacent.
The hypotenuse gets cancelled off in the ratio. So ultimately what we get is opposite upon adjacent. The basic, this is all we are going to use. So we're not going to use those trigonometrical like theorems and the ratios and all. Only these three components are used for our calculation. Okay. Now, why we are going to use this is because in the competency examination, see, on board we already get the volume of the oil. In the last class also, you all told me, where do you get the volume of the oil? Once I know the ullage, how do we get the volume?
Ullage table.
Ullage table. So in the ullage table itself, there are some corrections involved. Trim corrections, list corrections, and all these things are involved. So if you use ullage table correctly, we don't actually have to go into all these things. This we have to do in the examination. Why? Because in the examination, there is no ullage table given. So we have to find out the volume of the oil. Now, for finding out the volume of the oil, we are going to go back to our good old mathematics and trigonometry to find the volume of the oil. That is only the difficult part in the phase 1 examination. Once you find the volume of the oil, then it's a matter of simple using of the BCF and WCF. And once you have the volume in hand, getting the true weight or the weight in air is very, very simple. But just to get the volume of the oil, that's where the whole, it gets a little bit time consuming, because we are going to go into a lot of these trigonometrical ratios. All right. Now, again, we come to the same picture what we saw in the previous class. What is the effect of trim on the surface of the oil? Now, the tank is perfectly even keel. That means there is no trim at all. The trim is zero. This is how the tank will look like. So wherever we take the ullage, we can take the ullage from any part of the tank, anywhere in the tank length. The ullage will be same, exactly same. All right. On the center also it will be the same. The tank mid length also will be same on the after side or the forward side. But now what happens if the tank is trimmed? That means the forward draft is less, the aft draft is more. All the oil will come towards the after side. Why? Because oil always maintains a horizontal surface. So now here we have a problem. The oil has come on to one end of the tank because of the trim. And now how do we find out? So if we use the ullage port, if it is located exactly on the tank mid length, it will still read the same value. Why? Because the oil is hinging towards, this is a pivot point for the oil. If this one increases, this one reduces. So this is where it is going to pivot on. So if you measure it exactly on the pivot point, that is the tank's mid length, the ullage, there is no change at all. But we all know on board a ship, the ullage port is never on the midship. Okay, you may have something in the midship, but you also have in the off-centered towards the aft or the forward. So in case the tank is even keel, this would be the liquid surface. All right. Now, if we offset this particular ullage point to the aft, what will happen to the ullage? Is it the correct ullage?
No, sir.
No, sir.
No. Now there are 2 points coming into this. First of all, the ullage what is obtained is less. So let's look at this. There is a reduction in ullage. Why? Because all the oil from the forward, this triangle has gone and shifted towards this triangle. So that is the reason why we have a reduction in the ullage. And second part is this particular line is vertical line. The tank surface is, the oil surface is horizontal and this is vertical. But this violet color line, is it parallel to the aft bulkhead?
No, sir.
No.
No, sir.
Why? Because the tank is tilted. It is trimmed, and that's the reason why. So we have two problems in this. Okay. So at the same time, now if we use the radar gauge, what do we get? We have a reduction in the ullage, yes, but the radar gauge is actually following. It's parallel to the aft bulkhead. So strictly, there is some correction to be applied here too, because actually what I want is a level of the oil in this orange color line, the dashed orange line, and not the green line. So basically, this small correction what is involved is a trim correction what we follow about. This particular part, see, we are going to refer to only this particular part because I'm going to magnify this particular section and see what all concepts, what is all hidden behind this here. So this is again the tank structure. Now I want to make it very clear. This is the tank mid-length. This is not the forward end of the tank. This is the tank mid-length. So the tank mid-length is over here. Now this is the surface of the oil. If the oil is the tank is even keel, and now this is the horizontal level of the oil, and now this UO is the ullage which is observed by the ullage by the sounding pipe. Is it clear? This is a small offset which is given because the distance from the aft bulkhead is mentioned. I mean, it is given in the numericals or it can be obtained from the ship's plans and all. So this is what we get. You understand now what we have done from here. So from here, we have gone to this particular diagram where it expands, where it shows in more detail only from the tank mid-length to aft. The tank still continues forward, so that we are not looking at it for the time being. Is it concept clear?
Yes,
No?
Yes, sir.
Okay, all right. So again, looking at this particular diagram, so what we are interested in only this particular half to find these errors and all. So now this UO is what is obtained from the from that the sonic tape. Actually, what I want is UT. Now this is where the problem comes in. What we have in hand is UO, that is the observed ullage. But actually, what I want for calculation is UT. Once we get the UT, how do I get the volume of the oil, or how do I get the height of the oil? If we have UT in hand, how do I get the height of the oil?
It's a normal calculation, rectangle volume.
Yeah, rectangular volume. First of all, you have to find the height of the oil. That means, depth minus the ullage will give us the volume, the height of the oil. From there, multiply by length and breadth, you will get it. So this is the heart of all the calculations. This red color line, what is there? UT is where we are interested in finding the calculations. All right. So now this UT cannot be found out directly. So what we're going to do is we're going to split this UT into UP plus PT. All right. This UO, this blue line is a vertical line. This is the observed ullage. And this true ullage is UT, which is parallel to the aft bulkhead, so it meets our requirement. And plus, it is touching the even keel level of the oil, so it meets our second requirement also. So our main intention is to find out what is the UT. What we have is only UO, but we also know what is a trim. That means how much the ship is trimmed. That also we know. So ultimately, what we want to find out is UT. That UT can be split up into UP plus PT. Is uniform Papa and Papa Tango. This is what we are going to do. And this is what the whole calculation about in doing this is. So to find out this, what we do is we resolve two triangles. The first triangle to be resolved is UOP. That is U, O, and P. If we resolve this triangle, we will get UP. The second triangle to be resolved is PMT. That is, this is the center, the midpoint over here, M, P, M, and T. And so once we resolve the second triangle, which is like a horizontal triangle, right angle triangle, then we get what is called as a PT. Here. Now let's come to this. We see over here we have something called trim in theta. Now this trim is not in meters. This theta, this particular value is in degrees. So we are talking about trigonometry. That's the reason why we are going to measure this in degrees. Now tell me one thing. There is this theta over here. This is this angle over here, and this one more angle over here. Are they same or are they different? This angle and this angle. Would it be same or would it be different?
Different, sir. Should be different.
Should be different. Okay. Anybody else? Anybody else?
It should be same only because
it should be same. Why? Because
alternative angles.
Yeah, correct. Exactly. So now imagine this particular ship is perfectly upright and even keel. In that case, both the dotted line and the bold line, both of them will like coincide, and also this blue line will exactly coincide with this red line. Now, as this theta increases, this angle also increases. All right. So this theta is exactly same as this theta. So what we have is, this theta is caused because of trim. The same theta can be transposed over here, and we can also use the same theta over this particular theta value over here also. So we have the theta value is known to us. That means in a right angle triangle, we know the angle, and we also know one side. That means we can resolve all of the other missing sides. Clear? Now that is how we use. That's what the calculations what we use for finding out what are the values for UP and PT. The theta being common for both the triangles. Now let us see how we resolve it. First of all, this theta which is here, that is, the trim what we know is in meters, whereas what we want is in theta. So now this is a simple diagram of a ship. The ship is floating with the forward draft over here and the aft draft over here in the aft. And what is the value for trim?
Meters.
What is the trim value?
Meters.
Come on, guys, trim.
Meter. Aft minus forward.
Aft minus forward. So trim in meters is aft draft minus forward draft. That means this red line what we have over here is the aft draft minus the forward draft. This is what is called as trim. And again, I'm mentioning it. It is in meters. As of now, it is in meters. Our main concern is to convert into theta, into degrees. So now in this triangle, we have theta, which is over here, which is hidden between this the horizontal and the ship's keel. That is trim divided by LBP. Is it not? Tan theta is equal to opposite divided by adjacent. So tan theta is trim divided by LBP. Now theta value is tan inverse. That means what we do is we take out this tan and take it on the other side. So it becomes tan inverse of trim by LBP. Clear? So wherever the value for theta comes in, we can safely transpose it by putting as tan inverse of trim by LBP. We will get what is the value for theta. Is it concept understood?
Yes, sir.
Okay. So next we come to solve this triangle. The thing which was there, we want to find out what is UT, that is the true ullage. So that we are going to split up into UP and PT. So now in this triangle UOP, right angle at O, we know the value for theta, we know the value of UO. What is UP? So if I say cos theta is equal to adjacent divided by hypotenuse. This UP is a hypotenuse in this case. What we actually want is UP. So what we do is we say UP is equal to UO divided by cos theta. Or in other words, UO is equal to UP is equal to UO into secant of theta. Simple calculations. Let's not get into those the complexities of trigonometry and all. It's a very straightforward trigonometrical derivation. And now, as we already derived this value for theta, what is theta? In the previous example, the previous slide, what we did, theta is tan inverse of trim by LBP. So wherever theta comes in, we can safely transpose it as tan inverse of trim by LBP. Clear? Now this, by doing this, we get the value for UP. But that's only half the battle won. We still have to find out what is PT. So now for PT, we fortunately also have one more right angle triangle, that is PMT. So in this right angle triangle PMT, theta is known to us. And the theta is same as this tan inverse of trim by LBP. So theta is known to us. And PT is to be found out, and MT. MT, this whole thing from this, this is crank mid length. So what is the distance from M towards the aft bulkhead? From M to the aft bulkhead, what will be the distance?
Half of the
Half of
length.
LBP.
Half of length. Okay, so the length by 2 is basically this distance. Now, if I want to find out what is MT, so what we do is length by 2 minus this value for x. X is the distance from the aft bulkhead. So this value is also known to us. The length of the tank is given to us in the numerical. X value is also given to us in the numerical. So by doing L by 2 minus x, we find out what is the value for MT. So we do a very simple thing over here. Now, instead of tan theta, what we do is we put trim by LBP and into MT. So PT is equal to trim by LBP into MT. Now MT is also known to us, that is L by 2 minus x. So the value for PT can also be found out by using this simple calculation. Is it clear? Because this is where the heart of the whole calculation is, because of trim.
Good morning, Rajesh here. Can I add one thing?
Yes, please, Rajesh.
There's one place where most of the students do mistake.
Mm-hmm.
Last formula where you put this L by 2.
Okay.
they by mistake put LBP by 2. I've seen that in the class, so this they have to be very.
Okay. All right. See, LBP only comes up in this trim calculation when we actually take the whole ship. The moment we come into a tank, the moment we come into only, the volume in the tank, we always use L. So this L stands for length of the tank and not the length of the ship. So we don't use LBP too many times in this particular formula, only for finding out that the theta and only for finding out this particular value for PT. Otherwise, L is always the length of the tank. Yeah. All right. So now, again, like we said, so now we got what is the derivation of UP and what's the derivation of PT. So what we do is we just add up these two, and we get the value for this corrected ullage. Now, as we saw in the previous exam, in the previous slides, this let's look at two conditions where in one place we're using ullage tape, and one case we're using the radar gauge. Ullage tape will follow the path of UO, and the radar gauge will follow the path of UP. Can somebody tell me why?
Radar gauge is parallel to bulkhead.
Yeah, radar gauge is parallel to bulkhead. It is a fixed structure in the ship. When the ship is built, when the tanks are built, it is fixed structure. It will not go with the gravity. Whereas UO, this tape which is there, that is hanging because of gravity. So gravity will always take it vertical, and this level of the oil is always horizontal. And that is the reason why we have a small offset over here. Otherwise, this UP will always be used when, the UP is a value which is given if the radar gauge is used. That means there are there are kind of two variations over here. In one, we're using a tape. That means the tape will follow the path of UO. If you're using a radar gauge, the radar gauge will follow the path of UP. Correct. If you already have if you already have UP in hand, then we don't have to do any more correction, because the correction is required only because we have UO in hand. So if you already have UP in hand, that means in the radar gauge, we directly get the value for UP. So no further corrections to be applied in case of radar gauge. It's very, very important, because again, in the heat of the moment in the examination, because we have a simple formula, so we keep on continue to follow the same thing. So in case we use a radar gauge, we directly get UP, and this PT is trim by LBP into length by 2 minus X. That's in a bracket, and so we directly get if using a radar gauge, only corrections to be applied is the small PT correction to be applied. Is it clear? Is it clear? Any doubts?
Yes, sir.
So will you show the last slides about PT?
Okay, last slide for PT. This one?
Yes, sir.
Yeah, okay. And one more thing which I want to add is this UO, which was a sonic tape or a bob which is hanging vertical. Once we correct this UO to UP, that particular function is called tape correction. This correction, the one which is PT, is happening because the ship is trimmed, and this correction is called trim correction. So what we apply is, in case we use a sonic tape, or in case we use a sounding tape or something like that to find the ullage of the oil, then what we get is, we have to apply tape correction. From tape correction, we also apply trim correction to get the true ullage. Whereas if you're using a radar gauge, the tape correction is not applied. Why? Because we already have UP in hand. Only correction to be applied is the trim correction. So this PT is a trim correction, and this UP is a tape correction. Yeah, shall we go ahead?
One doubt, sir.
Yes.
Sir, this UO, you said that it is the sounding tape. So sounding tape is the sounding pipe is anyway to the trim of the vessel.
No.
So
on a tanker, we don't have sounding pipes, because the sounding pipes will actually, you'll have a lot of. So what we have is just a hole on the top, and from there we just hang the bob down. The sounding pipe, like what we have in the ballast tanks, will not be found in the oil tank, because they increase the shadow areas. They're difficult to clean, and then what is there in the shadow area of the sounding pipes can't be effectively cleaned, so they may like what you call like kind of interfere with the next cargoes and all. So what we have is just a hole on the top, and from there we put this bob down. Is it clear?
Sir, is alleged tapes and sounding tapes are different, or both
The
are
alleged tape and sounding tape is both are same in the respect that both are actually like what you call suspended from top. They're suspended from this point U, and they both use gravity to go down. But in the sounding tape, it is going all the way down. See, have you seen those engineers and all when they're using sounding tape to find out the ullage of the bunker tank? So the sounding tape can also be used to find the ullage. It all depends on how you. Let's say you pull it up to about 5 meters, you pick it up, and they see it's the oil is at 3 meters. That means the ullage is 2 meters. Or if you use something like a sophisticated equipment like UTI or MMC tape and all, then as we keep on suspending the bob, when it touches the oil surface, you'll get a intermittent beep will come, and that is what it is, which denotes that it has touched the oil level. So both can be used to find out the ullage. See, ultimately, what we want to find out is we want to find out this UO because we have to reach this UT. How to reach the UT from UO is basically this calculation. Okay, so even if the ullage is given from the sounding tape, you can find out the. You can take the value for UO, and then from there you calculate. Unless we come to some conditions where the sounding is given, then it's a different story altogether. But here we are only sticking to the ullage. That's the reason why we follow this particular calculation.
Captain Anand Subramaniam, sir.
Yes.
One of the question raised by participant Mr. Sambat Kumar Elangovan is the value of X in PT formula will distance of sounding pipe from bulkhead.
Yeah, distance of the sounding pipe from the aft bulkhead. Correct. That is the offset. That is the distance from the aft bulkhead.
Thank you, sir.
Okay, so let's go on. So once we know the ullage, which is given in the numericals, we first apply tape correction and the trim correction. But if a radar gauge is given, please ignore the tape correction because you already have UP in hand. So we directly apply the trim correction. That is the only thing. And the formula is this: UP is equal to UO into secant of tan inverse trim by LVP. It sounds pretty complex over here, but then when we do 2 or 3 numericals, this is very, very simple. When you compare those Haversine formulas and all the other formulas, what we do in navigation, this is all nothing. So once you do a couple of numericals, this equation also comes in automatic. Okay. Now, once we find out UT, that's I would say about 90% of the battle is done because we have the UT which is there. What we need to find out is the height of the oil, which is height of the tank minus UT. From there, we find out the absorbed volume of the oil, and from there we use the normal calculations, normal like what you call formulas and all. We find out GSV, and then find out once the GOV is known, then we find out the GSV, then we find out the density minus 0011, and then we find out the weight in air. This particular part is the most simplest thing. Unless you don't, you don't make a mistake in getting those factors. This particular part is very, very simple. All this difficulty is finding out the height of the oil. That is to find out what is this UT. Once we find out the UT, we can find out the height of the oil. Any questions so far?
Sir, excuse me.
Yes.
Can you please explain once again L by 2 minus X?
Okay, L by 2 minus X. Let's look at this particular thing. See now, let me go back. See over here, this is the tank center line, is it not? Why we have taken the center line? Because I'm going to magnify the whole thing. So what is this point from the aft bulkhead to this green line? What is the length of this? Is it L by 2? Length of the tank by 2. Why? Because we are going to magnify this particular section. I just want to know this particular triangle. That's the reason. And if you remember, I also said this M is a point where the oil pivots around because of trim. So from here, if we calculate, that's more or less okay for us. That means from this green line, which is the tank center line, to the aft bulkhead, that is L by 2. So far, so good?
Yes, sir, clear, sir, understood.
Yeah, okay. So now this distance from the aft bulkhead is X. What we need is MT. So this distance is equal to total length minus the value X, and that is by L by 2 minus X, which comes over here. So L by 2 minus X. This value for MT is transposed over here as L by 2 minus. Yeah. Any questions? If no questions, please take out a calculator. Let's do a very quick numerical. It's a very simple formula. I mean, very simple application. If you actually take out what you have to do is, I mean, for the first numerical, at least let's draw a diagram and do it. Otherwise, it becomes very, very simple. In the examination, of course, you draw a small diagram on the side, show these values, and then you can carry on. But to understand various concepts, it is better that you draw a diagram and then do it. So here we need to find out the weight of the oil. And what is given is a sonic tape. That is, it's a freely suspended object from the top. And the ullage is 1.8 meters. That is observed ullage. Tank dimension is given to us. Oil temperature is given. Density is given. If you notice the same density, same temperature, that means you can use the same DCF from the previous example. LBP is given and the trim is given. And this value for ullage point distance from the arc bulkhead is also given, 2.5 meters. Can we do this numerical? Anybody?
Let's try.
Yeah, okay, all right. So as always, first take on the given values, what was all given in the numericals. We can find out what is UO. That's all, it's all given to us. So you've taken on everything from there and draw a small diagram. It looks very nice because it shows that you've understood the whole concept. You can take out all these values and put in a figure that shows that you have understood this whole concept of this oil calculations and all. So the values are pretty straightforward. I mean, the equation is straightforward. So first what we want to find out is UP. So you can actually find out the whole thing in simply like what you call a single equation. But doing it for the first time, we can break down into small sections. Now remember, this is sonic tape. That means two corrections to be applied. One is the tape correction, and the second one is a trim correction. So this is the formula for tape correction. So UO into secant of tan inverse trim by LBP. Superimpose the values. What we get is UO is 1.8 of secant of tan inverse of 2 by 200. That is tan inverse of 2 by 200 is what this particular value. So 1.8 into secant of so much is this value, and ultimately what we get is UP, which is 1.80007. Any doubts here? Any like what do you call difficulties in this problem?
No, sir.
Okay. If you have a scientific calculator, you can do it in one single string and you'll get the same answer. All right. Next is what we want to find out is a trim correction, that is PT. So trim by LBP into L by 2 minus X. So trim by LBP is 0.01, that is 2 by 200, that's 0.01 into L by 2 is 12.5 because L is 25 meters. So L by 2 is 12.5. This value for X is 2.5. So 2.5 comes over here. So this becomes 0.01 into 10. That is 0.1. So PT is 0.1. So now we know what is UP and what is PT. So what is UT? Simple addition of these two. So true ullage is UT, which is UP plus PT. So 1.80007 plus 0.1, which is 1.9007. Now the big doubt in the questions, I mean in the numericals, how till what decimals do we go to? Now we are all using scientific calculators. So I mean, you see, actually you see the value of this is up to 5 decimal places. If you can go up to 5 decimal places, but finally when you come to the answers like cubics and metric tons and all, up to 3 decimal places is more than enough. Okay. So now once we have UT, we can find out what is the height of the oil. That is the depth of the tank, that is 15 meters minus 1.0007. Okay, that is I've done it wrong over here. Okay, the answer is 13.0993 meters. This is the height of the oil. Clear? Now how do we go to the volume, observed volume?
24 into 18 into 13.
Into length and breadth.
Into length and breadth, very simple. Okay, so find the observed volume, that is volume of the oil is, this is the first thing, like into the height, the length and the breadth. That means it comes to 5894.9685. Then we use a DCF. which if you see is the same as the previous example what we used. So what we get is GSV, that is the standard volume, that is what is the second step. Third step is find the density in air, density in vacuum, minus 0011. And lastly, we find out the weight in air, which is multiplication of this GSV by this 7839, which is 4570.234. Out here in these places, 3 decimal places is more than enough. Whereas if you can go to high decimals in those values where the dimensions are coming in. Otherwise, when we come over here after 3 decimal places is enough. Any doubts in this?
Will you show the last slide, sir?
Yep. You see, the complication comes up in the competency exam in finding out the allege. It is not the volume. Once you find out the volume, the correction is very, very simple. VCF, density minus 0011. If you get these 2 factors, we can directly, using the same string in the calculator, we can find the answer. The whole complication is about this particular value of getting the true allege. And that is where it becomes little complex.
Captain Anand Subramaniam, sir.
Yes.
What's the polling time?
Okay. All right. I'll take a small break here, 1 minute. You can look at the poll.
Sir, it is showing.
Right, Sandeep?
It is showing pole error.
Showing pole error. Okay. Moderator, can you have a look at it?
Okay, sir.
Okay, shall we proceed? Because there's one more concept for list correction, which needs to be looked into before we consolidate the whole class.
Yeah, you can go ahead. I'll just check that and relaunch it.
Okay. All right. Right. Okay. So,
sir,
yeah, tell me.
one question raised by Mr. Sahil.
Okay.
Explain how to find VCF.
How to find VCF?
Yeah.
Okay.
Yes,
the VCF was taken up in the first class. If you remember, last class I showed you one screenshot of the VCF tables, and then how to access it from using the observed temperature and the density at 15 degrees Celsius. So I would suggest please have a look at that the video which is there in the YouTube. And there we have explained in quite a bit of detail as to how to find out this VCF. Okay, and time permitting, towards the end, I'll come back to the VCF because it went off in one of my initial slides. Time permitting, I'll show it to you here also this class also. Okay, shall we go in? Any doubts in this so far? The trim correction.
Captain Anand Subramaniam, sir.
Yes.
One participant, Mr. Sam.
Mm-hmm.
He need to show the calculation of PT. Can you just show us the calculation of PT?
Okay, PT. Okay, all right. See, the formula looks pretty daunting, but then if you do 2 or 3 numericals, automatically this comes up. It comes up in a sequence. So there won't be any issues at all. And these values, trust me, these formulas are very, very simple as compared to those complex complex stability or navigation formulas what we have. This formula comparatively is much simpler. Okay, so that is it. I mean, that is about this particular calculation. And so find out what is the weight in air. Shall we go into the list now?
Yes.
Yeah, we'll come to these formulas again towards the end when we summarize the whole class. So we will come back to these formulas again. But let's finish off the list also. Again, the list is pretty much simple as I mean, it's very similar to as what we did for the trim. Here we have a ship. On the left hand side is the port side. That means I'm looking forward, and right hand side is the starboard. And we have a tank center line that's exactly in the center of these two. This is the breadth of the tank, and the ship is perfectly upright. So if you take an allege over here or allege anywhere on the deck surface, the allege is going to be exactly the same. But if the ship is now listed towards a port, again, if we if we have an allege pipe exactly on the center, like what we did for the trim correction, this is a pivot point for this particular tank also towards the transverse. That means if we have an allege point exactly on the center, then this also will give us exactly same allege. But the moment we go to any other side, either towards the port side or towards the starboard side, we will have an issue. So if we go towards the port side, this is the allege what we get from the tank top towards this green line, which is the horizontal line of the level of the oil. Actually, what I want is from the tank top to this orange line. So small correction has to be applied over here, and this correction is what positive or negative. I mean, should I? This has to be increased or decreased. Increased. Why? Because the oil surface has creeped up, and that is the reason why. I mean, the oil surface has creeped up. That means actually the actual allege is from the tank top to this orange line. If it is offset towards the port side, that means that is basically what is the UT and reduction of the allege, but parallel to the ship side. Okay. Now, if you have it in the opposite side, that means if you have, tank center line, we have it in the opposite side. That means allege point is offset towards the starboard side. Now, remember the tank is listed to port, but the allege point is towards the starboard side. Here, this much is the allege which I'm getting from the tank top to the green line. Whereas actually what I want is tank top to the orange line. That is our true allege. So there's a small amount of difference, a small amount of correction which needs to be subtracted from. So depending on which side of the tank the allege point is from the center line, the correction is either additive or subtractive. And that is why something we have to, that is the most important thing in the list correction. This doesn't really apply on the trim correction because in general, about 99.999% of the time, the for the longitudinally, the allege point is located very close to the aft bulkhead. It is always located after the center, the longitudinal center line of the ship of the tank. Whereas the transverse allege point can be located on the port side or the starboard side. So if the ship is listed to port side, port and port, the corrections to be added. If it is port listed to port and the offset is towards the starboard side, this correction has to be subtracted. Clear? So now if you go to the opposite side of the list, there is an increase in allege which needs to be subtracted. If you go on the same side of the list, some small correction has to be added up. Okay, like what we did in the longitudinal tank, we are going to look at only this particular section and let's see what really happens. Now this is tank center line, and this is the distance y which is given to us in the numerical. In the numerical, it will be given so and so allege point is let's say 3 meters, 4 meters from the center line of the tank. The midship center line, like what you call the breadthwise center line. And again, now that we are going to concentrate on the one half of it, this becomes b by 2. But here the b by 2 doesn't really come in the picture. Why? Because this distance y is the distance from the tank center line, and that is why we just written it as y. Now this the change of the oil level is because of list, and earlier we used the trim as theta. Here we use the list as lambda, LLTT. So the list is basically coming as represented as lambda, And this is a small list correction which needs to be done. That means what we have in hand is UN, but actually what we want to find out is UL. And so this NL is a small corrections to be added up. If it was located on the opposite side, that means if it was on the starboard side, the same NL has to be subtracted. Clear? So that is something what we need to be done. So correction NL to be applied to the observed ullage. And so in this triangle NLM, we know the we know the lambda, which is an angle of list. And what we want to find out is this value, and LM is already known to us because that is the distance from the tank center. That is the distance y, which is known to us. So tan lambda is equal to NL by y, or in other words, NL is equal to tan lambda into y. That's it, very simple formula. So this is a list correction to be added up or subtracted depending on the location of the time. See, the offset is towards the same side. That means if it is the list is to port and the ullage point is to the port, add it to the UO. If the list is to the opposite side, that means now in this case the list is port side. If this particular pipe was located on the starboard side, then we subtract. From the UO, we'll come to the final answer. The long equation. Then we'll come to know from where this is to be subtracted from. So now the calculation, in case you're using an ullage tape, now we are going to apply both list and trim. Okay. So the ullage is UO into secant of, see now this is tape correction. The first particular section is the tape correction. It's a trim component of the tape correction. This is a trim correction, the second half of it, the second section of it, and the last section is the list correction. And so the observed ullage, this is what we actually, when we finally do the whole calculation, it looks up like this. Is it clear? Now again, remember, this is a formula for using ullage tape. Ullage tape has got a tape correction. So ullage, the final ullage, the true ullage is tape correction plus minus trim correction plus minus list correction. If you're using only radar gauge, we don't have to do this particular step. Why? Because what we have in hand is already UT. The radar gauge already directly gives us UT. So if you're using a radar gauge, this is not required. So we directly go to the second stage and the third stage. Second stage is the trim correction. Third stage is the list correction. Now we have a notation over here plus minus. Over here also plus minus. The rules for the sign is, for trim correction, positive if the ullage stand is towards the trimmed end, which will normally be the case. 99.9 times it will be toward, the ullage stand will be towards that aft side. In case, to give a googly or something, in case the numericals, the question is asked, is put in such a way that the ullage stand is from the forward end, let's say 2 meters or 3 meters, then we have to subtract this. But this condition may not apply, appear in the MMT examination. What we normally get is ullage stand towards the trimmed end, that is towards the aft end. The notation for this plus minus over here, the rules of sign is, if the list correction, if both are the same side, add it. If both are opposite sides, subtract it. Very simple. Fine. So this is the actual formula to be used for your calculation.
Sir, in this, the value of x and the value of y remains standard all throughout. For instance, the x remains
in a particular numerical. Yes, in a particular numerical, the value for x is given to us. X is typically like 2.5 meters from the aft bulkhead, and y is 3 meters from the center line of the bulkhead, something like that.
Okay, sir. So that's always mentioned.
Yeah, it is given in the numerical. Of course, the numerical changes, the value for x also changes. So it's not a constant value. It is a value which is what is there in the numerical.
While doing it in MMD exam, can we directly put this formula and do it, or we have to explain?
You can. You can directly use the formula and do it. But there's only step one. In case you have time, it is always better to draw a small diagram. See, what in case you make a small mistake in these calculations, some way or the other, small clerical error or something, at least you will get some marks, at least 2-3 marks, at least 5 marks for the diagram what you draw. So diagram, if you ask me, is always welcome because that shows that you understood the concept. Even if you make a small clerical error some way or the other, the examiner will be giving a sympathetic view to the final marks what you get. Otherwise, you can blindly kind of memorize it, and you can get the right answer also.
Okay, just a reminder. It's 1 o'clock almost.
Yeah, okay. There is only one more numerical, and then that's basically, it's a very simple numerical. So, see, diagram, if you understand the concept, please draw the diagram. Once you do 2 or 3 diagrams, like what you shown in the diagram, it doesn't take too much of time. And we don't want 2-scale diagram. We just want a representation of the diagram.
So the list value will be given already, or you have to find the list value?
The list value is given. It will be given the numerical. So when we solve the numericals, you will get it. You will understand as to how this is done. There's only one last numerical to be solved. With that, you will understand how to get this list and trim both together. Okay. So now this is what we had in the initial parts. From ullage to volume to metric tons are the 4 steps. First find GSV, then find the density in air, then find the weight in air. This is a very, very simple step. The whole calculation comes up is basically like let's look at this particular value now. I've skipped few slides, and now we're coming to this calculation with trim and list. So here, take note, it's a radar gauge. So radar gauge, does it have a tape correction?
No, sir.
No tape correction. So what are the corrections to be applied to this radar gauge? The ship has got a trim and the ship has got a list.
Trim and list.
Trim correction.
List correction, that is all. Okay. So even if you don't bother to draw a diagram, at least you can like kind of get the values directly from there, and then you can get the answers. And I only want the height of the oil. If you find out the height of the oil, rest all is very simple. From the height you find out the ullage. From the height you find out the volume, and from there so on, so on, so on. Okay. So that's a very simple part. But here, what we want to find out is the ullage, and from the ullage, height of the oil. So again, as usual, what we do is we write down the given values. UP is 1.5. That is UP. Why UP? Because it's not UO. Because we're using a radar gauge. That's why we directly get the value for UP. The value for X. What is X? Aft bulkhead. So distance from the aft bulkhead is 3 meters. That is this over here. The trim is 2 meters. LBP is 200 meters, and the value for 3.5 meters to the port. That is 3.5 over here, and lambda is 2 degrees to starboard. Now remember, this is this is offset to port, and the lambda is starboard. That means they're opposite. If it is opposite, what is the sign for that particular list correction?
Negative.
Positive or negative?
Negative.
Negative. Okay. So now this is the formula to be used. Ullage is UT is actual ullage from the radar gauge. This is plus. Why it is plus? Because the radar gauge is the distance from the aft bulkhead is 3 meters. It is towards the trimmed end. That is why the distance. This particular thing is positive. This is negative here. This is a trim. This is a trim correction. This is a list correction. List correction is negative. Why? Because 3.5 to port and lambda to starboard. Opposite sides. That is why it is minus. Now quickly put the values for these. You will get what is the value for the ullage. So this true ullage is 1.4728. So what is the height of the oil?
Fifteen minus 1.4728.
15. The tank height minus 15 minus 1.4728. That is 13.5272. That's it. So you can directly use the formula and put on the values and do it. You'll also get the same answer. Once I get the height of the oil, the next step is volume. After I get the observed volume, then GSV to metric ton in air. Clear? Any doubts?
Sir, about the UT that plus is came from?
Plus is because if you remember the sign notation, it is plus because the ullage point is towards the trimmed end. See, how do I know? What is the length of the tank? Length of the tank is 25 meters. What is the half length? 12.5. So it is only 3 meters from the aft bulkhead. So it is still towards the trimmed end. The trim is towards the aft. Why? Because the trim is 2 meters. So the trim is towards the aft, and that is the reason why this is also positive.
Okay.
Both on the same end. But over here, if you see, one is on the port side, the list is on the starboard side. It's located on the port side, list is on the starboard. The same thing would have happened other ways also. So the opposite,
Understood.
it is minus.
Understood. Thanks.
Perfect. And, thank you very much for attending this class. Thank you very much.